here is part 2 of the review for exam 2. And this is specifically for college physics, but would be useful for anybody. Now, this as is the first question. A 7.5 kilogram order slides down a hill, starting from rest at the top. The sloping surface of the hill is 8.8 meter long, and the top is 6.5 meter above the base. So it's 8.8 meters long, and the height is 6.5 meter. If the speed of the order at the bottom of the hill is 9.2 meter per second, speed here is given, how much energy was lost to non-conservative forces on the hill? So when we say non-conservative forces, in this case it is friction. And to find the energy lost, the idea is to find the potential energy at the top, find the kinetic energy at the bottom, and take the difference between them. Because if the kinetic energy at the bottom is less, the energy was lost due to friction, which is the non-conservative force. So here we go. So the height, you have the distance, potential energy is mgh, and calculate that quantity, 4969 joules. And now find the kinetic energy at the bottom, which is 1/2 times mass times velocity square. Velocity is 9.2, get that. And you see that that quantity is considerably smaller than this. So take the difference and you get the energy lost. Which is 4,652 joules. And here is the second one. It's a 900 kilogram car traveling east at 15 meter per second suddenly collides with a 750 kilogram car traveling north at 20 meter per second. And the cars stick together after the collision. What is the speed of the wreckage just after the collision? So we need a diagram. And in this case, the idea is that the total momentum before collision is equal to the total momentum after collision. But you cannot simply add the momentum because momentum is a vector. So you got to take the resultant of the momentum along the east and along the north. So here is the diagram. So that is the diagram that shows the car moving towards the east, the car moving towards the north, and this is where both of the cars move after the collision. And put those numbers, 900 kilogram at 15 meter per second. The other one is 750 kilogram at 20 meter per second. And here we know that total mass is going to be together. Anyways, find the total momentum before collision. And since these are two vectors, like I said, you cannot add them. But one is along the x, the other is along the y. So simply square both, add them, take the square root. So I've just found the numbers first. 900 times 15 is 13,500. And 750 times 20 gives 15,000. So once you get those two numbers, square them, add them, take the square root. That gives the total momentum. So that's the total momentum before collision, and that must be the total momentum after collision. Now, what do we know after collision? We know that the cars are together, and so both are moving at the same velocity. So we add the masses and multiply it with the unknown velocity. So total momentum after collision is the sum of the masses, which is 900 plus 750 times the velocity which we are trying to find. Now, since the total before should be equal to the total after, we set them equal to each other. So before is equal to the momentum after. And then solve for the velocity. We get 12.23 meter per second. And here is the third question. A 340 gram air track cart traveling at 1.25 meter per second suddenly collides elastically with a stationary 300 gram cart. One or two very important words there. The most important of which is it is an elastic collision. So it is an elastic collision. And second, the 300 gram cart is at rest. What is the speed of the 300 gram cart just after the collision? First, we apply the principle of conservation of momentum. And we get, okay, so that's the diagram. Just showing the masses, 340 grams and 300 grams. Their velocities. First one is 1.25, second one is at rest. And we do not know their final velocities. We do not know both of their final velocities after collision. So applying conservation of momentum, mass is in kilograms, that's why it's 0.34, mass times velocity, and this one is of course 0, is equal to same thing, 0.34 times v1 prime plus 0.30 times v2 prime, because momentum is conserved or momentum is constant. And then we use the idea that kinetic energy is also conserved. But then that gives us a formula which can only be used for an elastic collision. Again, which can only be used for an elastic collision. And that formula is the difference in velocities before collision should be equal to the reverse difference after collision. Why am I saying reverse? So if I go V1 minus V2 here, I have to go V2 prime minus V1 prime on the right side. Now that gives us another equation, and therefore now you can substitute this into this equation for V2 prime, and so we eliminate V2 prime and we will have an equation only in V1 prime, and we can solve that. So that's what I'm doing now. So that is 0.425 and then 0.34 V1 prime. 0.30 times in place of V2 prime, I've substituted this whole thing. And then distribute these terms, multiply, distribute, and collect the terms that have V1 prime, add them up, take this term to the other side, subtract, and do that math. You're going to get V1 prime as 0.078 meter per second. And really we are asked to find V2 prime, which is the speed of the 300 gram cart, which is easy now. Just plug in the value of V1 prime into this. So that's how you do this problem. This is the fourth question, and this is a typical kind of question. You leave 100-watt light bulbs burning in the basement for 2 weeks. Who on earth would do that? Okay, because if you do that, you're going to just waste money. If electricity costs 10 cents per kilowatt hour, how much did the electricity cost? All right, so here what's important is this special unit called kilowatt times hour. So what you do is you just find the total number of hours for which the lights were left on, which is 2 weeks. 2 weeks is 2 times 7, 14 days. And each day has 24 hours, so 14 times 24. So first find the total number of hours. And then multiply the power, which is 100, with the total number of hours. We're going to get that as watt hour. And then divide it by 1000 because we want to change watt to kilowatt. Hopefully you understood that, but otherwise I'm going to show you. Kilowatt hour, okay? Total electricity used. Move that faster. is 100 watts times 2, because it's 2 weeks, times 7 times 24. That gives watt hours, because that's the total number of hours. And then because a kilowatt hour is 1000 watt hour, we'll divide this by 1000 and you get 33.6 kilowatt hour. Now that is actually called 1 unit of electricity, and then since we are paying 10 cents, and that's $0.1, you multiply that with $0.1 and you get $3.36. But that is the cost for one bulb. I almost forgot that there are 5 bulbs, right? Since there are 5 bulbs, you got to multiply that with 5 and you get 16.8. All right, so $16.80. And then you have to find how many joules of electrical energy did they consume. So imagine 1 kilowatt is 1000 watts, which is 1000 joules per second. So 1 kilowatt hour would be 1000 times, you got to change the hour into seconds, which is 3600 seconds, because 1 hour is 3600 seconds. So we get 1 kilowatt hour as 3.6 million joules. And since we know that we use 33.6 kilowatt hour, just multiply that with that quantity. So number of joules is just 5 times. Again, there are 5 bulbs. That's why I had to multiply it with 5. And you get this huge number in joules. That's how you do it. And I think I kept the best for the last, and this is a very good question. Need a lot of patience to understand this. A 200-gram hockey puck is launched up a ramp that's inclined at 30 degrees angle above the horizontal. The coefficients of static and kinetic friction are given. We really don't need the static friction because it's moving. We're only going to use kinetic friction. The initial velocity at the base is 3.8 meters per second, parallel to the sloping surface of the ramp. What speed does the puck have when it slides back down to its starting point? Hopefully you got the picture. So somebody's hitting the puck up. It's going up the ramp and then coming back down again. And it has friction when it goes up, and it has friction when it comes down. So there's going to be energy wasted. And if we can find out the energy wasted, then we can figure out the speed at which the puck returns to its starting point. So the diagram is very important. The puck starts from here, goes up the ramp. We complete this. The angle is 30 degrees. And we have to find friction. So I was trying to show how to find friction there. The weight, you have mg sine theta and friction. Alright, we really just need to find friction, which I found in this case. Friction, is mu k times the normal reaction. And in this case, the normal reaction is exactly equal to mg cosine theta. Right? Because we break mg into mg cosine theta and mg sine theta, the normal reaction is going to be equal to mg cosine theta. So that's why I have that. We do not know the mass, so we're just going to leave it as m. So 0.3, that's mu k, then 9.8 is g cosine 30m. That gives 2.55 times m. So that's the friction. Now, let's do it in 2 parts. First, it has kinetic energy here. When it goes up and reaches the highest point, it has potential energy. But some of the energy is lost due to friction. So if you add the energy lost by friction with the potential energy, you must get the initial kinetic energy. That makes sense? So that's what I'm going to do. The initial kinetic energy is 1/2 times mass times velocity square. That's equal to potential energy at the top, mgh, plus the work done against friction, which is force multiplied by distance. So we got the force of friction is 2.55 m, but we need the distance. The distance is not h actually, it is x. I'm going to change that. So we need to find a relation between x and h. We'll get there. All right, I've changed it to 2 times h, and I'm going to show you how I get that, because x is 2 times h. Why? Sine 30 is equal to h by x, right? Because sine is opposite by hypotenuse. So sine 30 is h by x, and sine 30 is half. So when you rearrange, you get x is equal to 2 times h. That's why you have 2h there. And then I have the numbers there. And I've just taken out the h from both quantities. So here you only have g. And here you have 2.55 times 2, which gives 5.10. And then so we can find the height. So you get the height as 0.48 meter. So next step is going to come back down. When it comes down, the potential energy at the top should be equal to kinetic energy at the bottom plus the work done against friction. So again, mgh is equal to 1/2 times mass times velocity square. We're looking for this velocity plus the work against friction. Force of friction is there. It's 2.55 m times 2h, same as before. It's coming down the same distance, right? So now you just got to calculate. So you have 9.8 times h, because we already have h from here, is equal to 1/2 times the unknown velocity square plus this is 5.10 h. Plug in the value of h here. I just forgot, but 9.8 times 0.48 is 4.7. So 1/2 this times. Okay, now I'm plugging in the value of h and then solve for velocity. When you solve it, you will get 2.1 meter per second, and that's how you do this problem. I hope you understand this review, but just studying the review will not do. You got to study everything, which is a lot, but that's how it is. But try to understand whatever you study. Thank you and good luck.